Today we're going to be reviewing systems of equations. We're going to be looking at solving by graphing and solving by substitution today. So a system of equations, if you remember from Algebra 1, it's just two or more linear equations. And this can be equations. This could be word problems that you're trying to figure out where you have to set up your linear equations. But we're looking at two or more linear equations and solving this system of equations. Well, when we're solving, what that means is we're looking for a point of intersection. Where do the two or more linear equations intersect? So we have three different types of solutions. We have one solution, meaning if we have two lines that intersect at one single point, we have one solution. Now, what happens if we graph two lines and they are parallel to each other? Meaning there will no longer be intersecting. So that means that there is no solution. So these are parallel lines. And then we have what we call infinite solutions. So if we were to graph these two lines, let's say we graph a line here, and then the other line that we graph lays on top of it. This is what we call infinite solutions, because it's the same line, so they intersect at every single possible point. So we have infinite solutions. Now, when we're solving our system of equation, what we're looking for is a point that makes both equations true. And we can do this three different ways: solving by graphing, solving by substitution, and elimination. Today we're just going to be looking at graphing and substitution. So when we solve by graphing, we want to solve each system of equations below. In order to be able to graph, we want to make sure that the equation, or both equations, are in slope-intercept form, because it's easier to graph, y equals mx plus b form, to graph. Now, don't forget, you might have some horizontal lines and some vertical lines, so just be aware of those when you are graphing. So we're going to do a few together. Problem number 1 here is going to be a nice and easy one. They're already both solved for y. So remember, when we are graphing, we always want to start with a y-intercept. So we always start at our b, and then we do the slope from that point. We do the rise over the run from that y-intercept. So we look at y equals negative 5/3 x minus 6. My starting point here will be my b value of negative 6. And my slope is negative 5/3. Well, if I try to go down 5 from here, I can't do it. So I'm going to go up 5 and then go to the left 3. So I'm going to make that 3 negative instead of the 5. So I'm going to go up 1, 2, 3, 4, 5, and then 3 to the left. So we have this point here. And if I keep doing that, 1, 2, 3, 4, 5, 1, 2, 3. See some points here, and I'm just going to connect these as best as I can. Try to use a ruler when graphing. It just makes it a lot neater, and you guarantee to always have that correct point of intersection. The next equation is y equals 1/6 x plus 5. So if I graph this one, starting with my y-intercept of 5, and my slope is 1/6. So I can go up 1 and 6 to the right, or I can go down 1 and 6 to the left. And I can see right there where they are going to intersect. They are going to intersect right at this point right here, negative 6, 4. So my solution to this system of equations is negative 6, 4. That is where they are the same value. So if I were to substitute in negative 6 and 4 into both equations, they're going to come out to be true statements. Next, I want to jump down to number 4. Notice that here, that first equation is not solved for y, so I need to solve for y here. So first thing I'm going to do is I'm going to move that 3x over as a negative 3x to this other side. And then I'm going to divide everything by 6. That leaves me with y equals negative 1/2 x minus 2. And now I'm going to graph that one, starting with my y-intercept of negative 2. My slope, I'll go down 1, 2 to the right, and I'll just keep doing that slope to get more points. The more points you plot, especially if you're doing this on paper, the easier it is to graph. Of course, on Delta Math, it'll probably graph it for you. Oh, a little off there. All right. And y equals negative 1/2 x minus 5. I'm going to do that in a different color. So now my y-intercept is negative 5, but my slope is the same. And you should remember from Algebra 1 or geometry that when our slopes are the same and the y-intercepts are different, we have parallel lines. And if we have parallel lines, these were never going to intersect. And if a solution to a system of equations is the point where they intersect and they don't intersect, there is no solution here. You might see that on Delta Math as this symbol. This means no solution, or the empty set. All means the same thing. So here there is no solution. If we look at number 6, I need to solve for y on both of these. So for this first one, all I need to do is divide everything by a negative 1 or multiply everything by a negative 1 to get rid of that negative in front of the y. So all that really does is changes all the signs. So y equals x plus 6. If I graph that, starting with our y-intercept of 6, my slope is 1. There's a 1 in front of that. So up 1 to the right 1. And just keep on going. See here where my line is going to be. It's a little off there. All right. And then my next one here, I'm just going to divide by 3. That leaves me with 1x plus 6 equals y. Oh, those are exactly the same. And notice that they're the same. So they're the same equation. That means when I graph it, it's just going to lie on top of it. Meaning there is an infinite number of solutions. They are going to intersect at every single point. So again, with graphing, you just have to make sure that everything is solved for y, and then you just graph to solve. In class, I will be showing you how to use a calculator, a graphing calculator, to use your intersection button so you can get your solutions. Next, we're going to look at solve by substitution. So there are some steps where we're substituting. When you want to make sure that when you're using substitution, you want one of the equations, at least one of the equations, to be an x equals or a y equals. So we want an x equals or a y equals. And the reason is when we substitute, what that allows us to do is have an equation with just one variable instead of an x and a y variable. And it makes it a lot easier to solve. I highly recommend, if you're doing this on paper, make sure that you use parentheses when you are substituting. Also, it helps if you have a highlighter. Just so you can identify what you're substituting. Using a highlighter sometimes kind of helps for that. Once you substitute from one equation into another equation, you're just going to solve for whatever variables in that equation, whether it's an x or a y. Once you have that, you're going to substitute your answer from step 3, from this one that you did right before, into either original equation. It doesn't matter which one you substitute into. I always recommend substituting into one of the ones that are already solved for you, x equals or y equals. Just makes it so you don't have to do as many steps. I'll show you what that means in a little while. So with problem number 7, what's nice about this one is both of them are solved for y. Y equals y equals. So what that means is I can substitute this 7x minus 1 into the y value of that other equation. We never substitute into that same equation, just into the other one. So what this looks like is, instead of y, I'm going to replace it with this negative 7x minus 1. And then on the other side is going to be this x minus 9. Now I have one equation that has one variable. This lets me know I'm going to solve for x first. So in order to do that, I'm going to add 7x plus 7x. Then I'm going to add 9 to the other side. So x equals 1. So I have the x coordinate of the solution, and now we're going to substitute into either one of the two original equations. I am going to use this one here just because there's less things for me to do. And then remember, when we're substituting, always use parentheses, because if it's a negative, it just makes it a little bit easier to not make careless mistakes. So 1 minus 9 is negative 8. So if I were to graph this, my solution where these two lines would intersect would be 1, negative 8. So be really careful when you're looking for a solution. Your answer will be as an ordered pair, unless they ask you for the x value of the solution or just the y value of the solution. If they ask you for the entire solution, it's the whole ordered pair. Now, if we look at something like number 8, we can see here, unlike number 7, where both of them were solved for y, only one of them is solved for y, and that's all we need. Solve one equation for x or for y. So I don't have to do any work here for step number 1. I know that since I have y equals, I'm going to substitute negative 5x plus 30 into the y value of the second equation. So when I write this down, 7x plus 3, I'm going to use parentheses to show my substitution. I'm replacing that y with negative 5x plus 30. And now notice that we have an equation with just x's. I'm going to solve for x here. So 7x minus 15x plus 90 is equal to 42. I'm going to combine our like terms here. This leaves me with negative 8x plus 90 equals 42. Subtract 90 to the other side. We get negative 8x equals negative 48. And then we divide both sides by negative 8. X equals 6. Now that I have that x value, I can plug that x of 6 into the first or second equation. The first one's going to be the easiest because it's already in y equals. That's what I want to find. I want to find my y. So I'm going to use this equation to see what y equals. I have a negative 5. I know my x value is 6, so I'm going to replace that with 6 and then add 30. Y equals negative 30 plus 30, so y equals 0. So my solution is the ordered pair 6, 0. Let's go ahead and jump down to number 10 here. And I wanted to do this one because if we're looking at both of these equations, notice how nothing is solved for me. I then need to make the choice of what to solve for. So when we're solving one equation, we want to choose the easiest, can't spell, choose the easiest variable to isolate. So in this case, if I'm looking at number 10, the easiest one will be this x right here. Because I'm just going to move that negative 7y over as a positive 7y. So x is equal to 7y plus 53. So what I'm going to substitute here is this 7y plus 53 into the x of the second equation. So negative 4, and again parentheses because we're substituting, 7y plus 53 minus 5y equals 19. And now distribute, solve. We get negative 28y minus 212 minus 5y equals 19. I'm going to combine like terms here. Negative 28y minus 5y gives me negative 33y. Minus 212 equals 19. Add 212 to both sides. We get negative 33y is equal to 231. And then we divide by negative 33. We get y equals negative 7. So now we have the y value. We have the y value first. So we're going to plug that y, and I want to solve for x. So instead of plugging into this original one, I'm going to use the one that's already has x equals, because this is what I'm trying to solve for. I'm trying to solve for x. So x equals 7 times, well, my y is negative 7, plus 53. So x equals negative 49 plus 53. X equals 4. So my solution is the ordered pair 4, negative 7. Be very careful. Some people will want to put negative 7, 4, and that is wrong. Just because we did solve for the y first doesn't mean that that's the first number in my ordered pair. Remember, it's an x and then a y. And the last one we're going to do, number 11. So we have 2y equals 6x plus 10, and then we have 3x minus y equals 5. So looking at this one, yes, I could solve for y here and move the 3x over and then divide everything by negative 1, or I see that I have a 2y here, and 2, 6, and 10 are all divisible by 2. So the easiest one to do here is this one. Solve for y just by dividing everything by 2. So I'm going to substitute this 3x plus 5 into the y of the second equation. So we have 3x minus, and then in parentheses, what I'm substituting, 3x plus 5 equals 5. So when I distribute, we get 3x minus 5 equals 5. When I combine here, we get 0. So we have negative 5 equals 5. This is not true. This is a false statement. And because it's false, therefore there are no solutions. There will not be a single ordered pair that will ever make these two true. What that means essentially is if I were to solve for y on both of these equations, they would both have a slope of 3, and they would have a different y-intercept, meaning they would be parallel lines. So be really careful when you're solving. Anytime you cancel out variables and you're left with just a statement like this, look at your statement. If it's false, there are no solutions. Now, if you're left with 0 equals 0, that is a true statement. That means there would be an infinite number of solutions. So be really careful. If it's true, there will be an infinite number of solutions. So what we're going to be doing in class is we're going to be looking at using what we know about systems of equations and solving those with real-world situations.